Welcome back to Algebra 2. Let's take a look at simplifying these operations. Some of these are multiplication, one is division, and we have one that is taking a look at what the heck happens when we have expressions instead of just numbers. Please pause and try these. So when nothing simplifies, we simply multiply straight across 10 over 21. We can have things that simplify, and the reason that this is not 72 over 50 is because both of those numbers are divisible by 2. And we could have determined that earlier, that 8 and 10 are both divisible by 2. Anytime we see division, we need to recognize it is copy dot flip-flop. And that means 4 over 11 times 3 over 2, and that will simplify to 6 over 11. When we multiply, we're still multiplying straight across to anything that has something unusual in it. We're going to put parentheses around. We do want to multiply that, so I'm going to distribute the 2, and that gives me 2x minus 2 over 25. So our first objective for this section is to simplify rational expressions, so that means it's going to include variables, could be in the numerator or denominator, with multiplication. When we simplify rational expressions, the first most common thing we do is factor out common factors. So we want to look at both of these things are divisible by 5, so we can do that, and the 5's will cancel out. We can also do that with variable expressions as long as it is written as factors. We cannot have this written out in the multiplication and scratch things out randomly. They have to be factors in order for us to do this. The last thing that I want to be able to do on this one is there are some limits to the domain here. Anything that was in the denominator is not allowed to equal 0. I have a dog sneaking in here, sorry. And that means that x cannot equal negative 3. So when we simplify these, hey, wouldn't it be nice if we could go 4 goes into this 3 times, and this goes into this? Now, we can't do that. That is not allowed. Hi, Jazz. Okay, I was wondering who was sneaking in here, Jazzy girl. Okay, good girl. What we have to do is factor. So I'm going to start out by factoring the numerator, and that means what are the two things that multiply to give us negative 12 and add to give us negative 4, and that's going to be negative 6 and positive 2. So numerator factored. Now we factor the denominator for the same reason. And we see the difference of perfect squares. So we're going to do x plus 2 and x minus 2. Now that things are factored, every single thing is written as times. This is an expression times an expression. Now I'm allowed to go in and say, hey, I've got x plus 2 on the numerator and the denominator. That's great. What that gives me, oops, I'm not even going to write the parentheses anymore. One term across the top and one term across the bottom. Now that's simpler than the original problem. I just have a slight problem. Absolutely anything that was in the denominator is not allowed to equal 0, or I'd be trying to divide by 0, and I'm not allowed to do that. So when I set these up and solve them, I do have to put some limits on here, and say, oh, by the way, x is not allowed to equal positive or negative 2. So that is what I want as the final answer. Two things. What is the simplified expression? And by the way, what can't x equal? Because if I plugged it in that way, the equation would be dividing by 0. Always think in terms of factoring. If I can factor, or it's already factored, I can go, hey, yay, those two things go away. So my term is going to be much simpler. But every single thing that is in the denominator, even if I cancel it out, cannot equal 0. So in this particular case, this is going to be x cannot equal -1 or -3, and I'm just going to circle my answer that way. If anything is not factored, you must factor. And this is going to be the difference of perfect squares. Now they're in parentheses to show that they're multiplying everything out. And, hey, great, these cancel. What am I left with? Am I really left with just x minus 4? Or is there something in the numerator that we need to show? There's something in the numerator. The last step I need to say is, by the way, each of these two things in the denominator cannot equal 0. So that is going to give me positive or negative 4 are not allowed. There are two parts to the final answer. Please make sure you give me both of them. Now, it might be that nothing factors. That's fine. I still have this. I am going to multiply it back out to give me x squared plus 2x in the denominator. But I still need to say, oh, by the way, x cannot equal 0. And x plus 2 cannot equal 0, giving me a -2. If it is not factored, factor it. In this case, I need to factor both the numerator and the denominator. Now, the two things that multiply to get me -3, so that's going to be x minus 3 and x plus 1. And multiply to give me -6 and add to give me positive. Okay, these two things cancel. However, x minus 3 still cannot equal 0, and the thing that remains in the denominator cannot equal 0. So what I'm left with is x plus 2 in the denominator, x plus 1 in the numerator. And what can x not equal? Cannot equal positive 3 and -2. Make sure you have the two parts to the answers. Now we're also going to see things that don't have any addition or subtraction in them. They are just all multiplication. We can multiply things out and say, okay, things on the top multiply to 30. How many x's do I have? How many y's do I have? So I could set it up this way first and then simplify, or I can write out the individual factors and then cancel factors as I see them. I tend to be pretty quick to go and cancel things. 2 goes into 6 3 times. With my variables, if I cancel this x into this x squared, it doesn't cancel the x, it cancels the squaring. Same with x, y cubed and y squared, these two guys here. Y squared is going to subtract 2 from the power. So that's another way that I could set these up. In all cases, I'm going to end up with 3x squared over 2, and anything that was in the denominator that is a variable cannot equal 0. Okay, so what are we going to cancel out? 2 goes into 8 4 times. 4 goes into 4 once. Y goes into y. Y squared, I'm going to subtract 2 from this power. X, I'm going to subtract an x, so that's going to make that a 2. So I can write them all out as I go here, and that's going to give me 7 in the numerator. X to the 4th times x squared times x to the 4th is x to the 6th. Y to the 3 minus 2 is y. So that would be my final answer. I can also write them out as factors and then cancel them out that way as well. Both ways work. So if I want to write these out, in the numerator I have 4 times 2, that's 8, x, 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 y, 7, and 2, 3, 4, y, 2, 3. Okay, I have a 2, x, y, y, 4, y. Okay, I can actually write out every single x, every single y. If this makes it easier for you to factor out, that's fine. 2 cancels, 4 cancels. This y takes off 1. This one takes off 1. This one takes off 1. This takes off 1. Okay, what do I have left in the numerator? 7. How many x's? 1, 2, 3, 4, 5, 6. How many y's? 1. Same answer both ways. Okay, do not multiply the factors first. You're going to get ugly things and you're still going to have to divide them out. So I have 4 separate parts here, and I am going to factor out each separate one. Now this guy down here doesn't look like he factors at all. Everything else I'm going to factor. In the first part here, I notice that I can factor out a 3x. When I do that, 3x divided by 3x is 1. 3x squared divided by 3x is negative x. In my next term that I'm going to factor things out on, what do things multiply to give me negative 20 and add to give me positive 1? That's going to be x plus 5 and x minus 4. Over here, what do things multiply to give me negative 5 and add to give me positive 4? That's going to be plus 5 and x minus 1. So each different part is factored. I'm going to clean up what I can. 3x goes into 3x. X plus 5 I see in 2 places. These two things look close, but not exact. So now let's take a look at just that part. Now, this guy and this guy, the difference is the minus sign is on the wrong thing. So what I need to do is factor out a negative, which is going to change both of these signs. What that does for me is change this to an x minus 1. Now these two things do cancel. And I am left with, I'm going to distribute the negative, so negative x plus 4. But I originally had things in the denominator. I actually had 3 different factors in the denominator. I had 3x, that's not allowed to equal 0. I had x plus 5. Even though it's no longer in there, it was in there. So I have to honor the original problem. And because of those 3 things, I need to say that x cannot equal 0, -5, and +1. So it can turn out that my final answer isn't even a fraction anymore, but I still have to include the limits on the domain based on the original problem. Now I would have problems factoring this if I did not recognize that this bottom one is called the difference of perfect cubes. And the difference of perfect cubes is written here. And I need to figure out what a is. And a is the first term taken cube root of. That's going to be x. And b is the cube root of the second term, and that's going to be a 3. So across the numerator, anything that wasn't in parentheses probably should be in parentheses. Can I factor this guy? It is in the numerator. What 2 things multiply to give me 9 and add to give me 3? Nothing. And if I try it even with the quadratic formula, I'm going to find that the answers are imaginary. So now I'm going to do the perfect cubes. My first term is a minus b. The second one is a squared plus a times b, x3 is 3x, plus b squared is 9. And now these 2 things will cancel. Now I do need to set each thing in the denominator equal to 0, but what I will find is this is the only one that isn't imaginary, so x cannot equal 3. There is also an equation for the sum of perfect cubes as well. The plus and minus signs will change a little bit. Okay, let's start out by taking a look at problem 6. Let's take a look at problem 5. So in problem number 5, I'm going to cancel out things that I can. 3 goes into 9 3 times. 3 goes into 6 twice. 2 goes into 8 4 times. I have x to the 5th, x, I've got an x down here, so I'm just going to cancel these 2. X cubed goes into x to the 5th. That means I need to subtract 3 from the power. Power is now 2. Y squared, this cancels with that one, and this cancels the rest of it. So across the top I have x squared, y squared. In the denominator, the only thing I have left is 4, but the 2 variables that were in the denominator are not allowed to equal 0, or the problem would cause problems. I need to factor everything I can, and that can include factoring a common factor out. So I have x minus 5. My next term should be in parentheses. In the denominator, I recognize this as the difference of perfect squares, one being a minus and one being a plus, and 2x squared. So what kinds of things factor out? X minus 5. Now, 2 factors out. X factors out, making this a 1. Doesn't get rid of the x, it gets rid of the power. So I do need to multiply the denominator back out. So I end up with x plus 3 in the numerator. X times both of these is x squared plus 5x. And every single one of these terms that is in the denominator cannot equal 0. So that is going to include positive 5, negative 5, and 0. Okay, for our last problem, problem number 7. Making sure that we know this goes into the numerator, we're going to try to factor everything out in the numerator. And x plus 5, that's as good as it gets. The second thing that's in the numerator, what two things multiply to give us 1 and add to give us 1? That doesn't happen. Those solutions are actually imaginary, even if we use quadratic formula. Down below here, we need to use the difference of perfect cubes, with a being x and b being 1. Cube root of this, cube root of this. Difference of perfect cubes. We're going to start with x minus 1. Then we have a squared plus a times b plus b squared, which nicely gives me two factors that cancel out, leaving me with x plus 5 in the numerator, x minus 1 in the denominator, and x is not allowed to equal. If I could have factored this, it would have given me more, but we are done. So today you will be working on multiplication, and then tomorrow you will work on division problems. Homework is on Google Classroom, and have a good day.